So we are talking about to calculate the value of gravitational force. Now let us take an example that we have Earth and we have Moon, and we have to find the gravitational force of attraction between Earth and Moon. So what do we want? First of all, I want mass of Earth, I want mass of Moon, and I want the mean distance of separation between them, so that I could apply the formula that F is equal to G m1 m2 upon r square, right? So this thing, the mass of Earth is approximately 6 into 10 raised to power 24 kg, whereas mass of Moon is approximately, it is 10 raised to power 22. I don't remember I have to look at 7, it should be 7.4 I guess. Yes, and then the mean distance of separation is about approximately 3.8 into 10 raised to power 8 meters. These are the values. So how do we use this formula? Just pour in the values. What is the value of universal gravitational constant? It is 6.67, but we are taking at 6.7 into 10 raised to power minus 11. m1, mass of Earth, 6 into 10 raised to power 24 kg. Then mass of Moon, this is 7.4 into 10 raised to power 22. And then distance square. I have to square it out. So I will be writing it as 3.8 into 3.8 multiplied by 10 raised to power 8 square is 10 raised to power 16, because powers just get multiplied. So into 10 raised to power 16. If we just calculate this thing, 10 raised to power, just take the powers, we have 6.7 into 6 into 7.4 divided by 3.8 into 3.8. Let's check what is the power coming up. It is minus 11 plus 24 plus 22 minus 16, because this 10 raised to power 16, when it will be taken to numerator side, it will become negative. So 10 raised to power minus 16. So we have 24 plus 22, right? What is this? 46. And we have 11 and 16. This is 46. We have 11 and 16. This is 27. So if I'll subtract 46 from 27, what will I get? This is 16, so it will become 9, and this is 319. So this becomes 10 raised to power 19. So actually this calculation comes out to be 20.1 and something into 10 raised to power 19. So we are going to shift a decimal there and it will be multiplied by 1. So it becomes 2.01 into 10 raised to power 20. What would be the units? Kgs, right? No. Force, we are calculating force. So force is in newtons. So this is newtons. This is how we use this formula. Alright. So this formula can be applicable. This formula is applicable everywhere, anywhere where we have mass of two bodies and we have a distance of separation between them. Now, have you ever heard about the word gravity? Have we? See, gravity is often used when we are finding the force of attraction of one body with respect to Earth. So that gives us a clear indication that the word gravitation will be used when we are talking about any two bodies in this universe, any two bodies. But the word gravitation will be changed to word gravity when one of those two bodies is Earth. Is that simple? So what was gravitation? It is the force of attraction between any two bodies in this universe. And what is gravity? Gravity is the force of attraction between any other body and Earth. So this is what gravity means. So gravity is when one of the bodies is Earth and second one is any other body. Now, what do we mean by free fall? That is what my point is. I am coming to that point. What do we mean by word free fall? When we jump from some height, momentarily we find ourselves weightless. We feel that we don't have any weight. What is weight, by the way? Weight is We know weight is mg, mass into gravity. Now what is acceleration due to gravity? All these things are actually linked from here only. First of all, before going on to what is free fall, we are going to talk about, I just mentioned you gravity. Suppose this is earth, this is radius of earth. I have taken a small mass m, this is capital mass m, okay, and I want to find what is the force of attraction between earth and this body. The force of attraction is the gravitational force of attraction, which is g m1 m2 upon r square, where r is the radius of earth. How much is the radius of earth? It is 6400 kilometers. All right, now 6400. So this is the formula, but this body is being pulled towards center of earth with a force which till date we call it as what? Weight. And what is weight? Weight is m into g. So basically now we know the gravitational force of attraction applied by earth is actually causing weight of the body. So that means this mg is equal to g m upon r square. From here I'll get acceleration due to gravity is g m upon r square, and from this formula we can find out the value of acceleration due to gravity on earth. What is that? Small g is g m upon r square. What is g? 6.7 into 10 raised to power minus 11. What is mass of earth? 6 into 10 raised to power 24 kg, and radius of earth is 6400 kilometers. I'll rub it out though. I want to write 6400 kilometers, right? So what should I do with the kilometers? Into 10 raised to power 3 meters, right? Instead of writing like this, I'll be writing, I'm taking these two zeros here as well. So now it becomes 64 into 10 raised to power 5 meters or 6.4 into 10 raised to power 6 meters, right? So this is radius of earth and I want to square it up. So this value will be approximately 9.791 something, and we even approximate that 9.7 to 9.8 meter per second square. This is the acceleration due to gravity on the surface of earth, because we kept the body on the surface of earth. That means if I keep another body at some height, so I will be considering this radius plus this height as well. So in the formula, the distance between the body is what? G m upon r plus h. It will become r plus h square. That means acceleration due to gravity on a body which is at some height would be different. It won't be 9.8. That means acceleration due to gravity is not a fixed value. That means it is not a constant. So what is constant? The only thing constant in this chapter is universal gravitational constant, whereas acceleration due to gravity is not constant because it changes with height, it changes with depth, it changes with the radius. Acceleration due to gravity changes everywhere, right? So now we know what is force acting on a body on the surface of earth, which we were calling weight. It turns out to be it's a force of gravitation, and when we equate these two things, we'll get acceleration due to gravity is g upon r square. We put on the values, we'll get this is 9.8 meter per second square. And then we are coming to what is a free fall. Now, what is weight? I hope you have made this diagram. So I want to talk about what is weight. When we step on some weighing machine, what do we see? We see our weight, right? Though it is measured in kg because the whole device is calibrated in such a way that g is automatically taken into consideration and we are actually finding the mass. So before again moving on to this, we have to talk about what is the difference between mass and weight. Okay, what is mass? Mass is the quantity of matter contained in a body. So that is, my mass is 60 kg, that means the quantity of matter contained in my body is what? 60 kgs. What is weight? Weight is the force with which earth attracts us towards its center. Why I'm calling it again and again towards its center? Why not anywhere? Just earth is attracting, that's it. Let's keep it in layman language. Why not? We have to keep it in a very scientific language, that the force with which earth attracts us towards its center. That is because, suppose, what is my height? Let's say 6 feet. But let us assume for a minute that my height is 6,000 feet. something less than average. It is 8848 meters. So let's say my height is 6,000 feet. Okay. So if you see Earth from above, and if I am that much long, I'll be something like this. Okay. That makes sense. I'll be 6,000 feet in that case. So if anything which is in this direction tends to fall downwards, but this body, which is me virtually, will not fall anywhere because it is being pulled, this body is being pulled towards center of Earth. That is what weight is. Weight is the force with which Earth attracts towards its center, whereas mass is the whole quantity of motion contained in a body. So now we know a clear difference between weight and mass. And finally, we can talk about weight. What is weight? mg, right? But consider a lift, and we are taking 3 cases. Let's put a man in the lift in all these 3 cases, and let us stand the man on a weighing scale, a device which we generally use to measure our weight. We call it weight, it gives us mass, don't keep any confusion between it, right? So when it is standing still, whatever it is being measured is weight, which is mg. But if this lift, because we placed the man in the lift, and if this lift starts going in upward direction, it will experience a force in downward direction. That is true. So the weight tends to increase, right? Weight becomes m times g plus a. What is a? A is the acceleration with which the body is going upward. Now, how do you understand this concept? It is simple. Sit in a car, actually sit in a car in the back seat, not in the front seat, and ask the driver or anyone who is driving that accelerate the car very fast. Don't do it on a rushy road, just it's a simple experiment, so do it on a very vacant road, okay? Or just don't do it, ask some of your friend who has done it. So sit on the back side. When the driver accelerates car very fast, the car goes in front direction, but you will be observing a backward push towards the seat. So that push is actually a pseudo force. What is pseudo force? Pseudo forces are forces which are generated by themselves. Okay, so that force is always opposite to the applied force. Now go back to laws of motion. What is force on a body? F is equal to m into a. The body, this whole lift is moving in vertically upward direction, so it is going with an a acceleration. That means force acting on the body would be ma, but there would be a opposite force which will acting on the body in the downward direction, pressing the body against the floor. That will increase the weight. So the simplest formula is weight is equal to mass times g plus a. So that means if the lift starts going vertically upwards direction with some acceleration, the weight will increase, and the converse will also happen if the body is going in downward direction. So the weight would be m times g minus a, because the pseudo force will be acting in the upward direction, right? It will tend to bring the body towards the roof of the lift. Now I am talking about free fall. Suppose I don't like this guy, I just cut the rope. What will happen? The lift will fall. When the lift is falling, it will be falling with which acceleration? The acceleration due to gravity. A is equal to g. So when A is equal to g, what would be the weight? M into g minus g, m into 0, which is 0. So weight is 0. That is called weightlessness, and this phenomena is called free fall. That is, when you are falling under the effect of gravity, you will not experience any weight, you will be feeling weightless, and that is called free fall. Hope I have made you this whole topic very clear.